You're not gonna go. Nope.
Thumbs up when you're good here? Oh, not quite, huh? A little bit. Okay. I just want to give you a chance to look at it before I move on. You guys know I have a twin sister?
Yeah.
She's up there. Yeah.
She never come in when they were
She's a doctor, and I do not feel comfortable switching with her for the day. So
like on her day off.
On her day off, have her come in.
She lives like 8 hours away, so unless for some reason she wants to come and see you guys on her day off.
She doesn't much of like a career. Like,
We all have the same voice. We all have the same voice.
Well, then you would have to
I can't tell which one. Do you guys have the same?
Which one is you?
Wait, Megan's got.
Oh, guys.
It's probably
Oh, it's the one taking the picture.
Yeah,
It is me. Yeah.
Yes.
Fluffy. So anyway, that was a prompt to get me into the example on the board. So we were really goody two shoes in high school, but occasionally, you know me, B up here. There's B. There's me. And this is sister. This is me. So she's Y and I'm B. That's what we did. We did. So we switched boyfriends for the day.
Oh, yeah. Are you serious? Y'all are terrible.
So A got with who? So here's AB. Hold on. Plus XY. A got with sister's boyfriend. Didn't know he was a turd. And then B. Actually, I lied. This was Sammy. This was my sister. She got with my boyfriend. He knew. And he's my husband now, so, you know, it worked out. All right, so then, right now?
No.
My high school sophomore self married my high school sophomore boyfriend.
Wait, you just married him.
No. I switched. He knew, though. That was the trick. We had to make sure he figured it out. He knew, but the other one didn't. He got
actually a good test.
because if he didn't know who I was, live SmackDown.
Yeah,
Okay?
everything's
So, yeah. You gotta be careful with twins. Does anybody know twins? Yeah? Okay, you gotta be careful. They're sneaky. Okay, so anyway. That's way off topic. I'm reeling you back in. Okay, so regardless, what you should realize is in chemistry, we can't stray from positives and negatives attract. I know it's the 21st century. Anything can attract anything else, but we have positive and negative here. So we have A, which is acting as a positive. B has to be a negative. And A gets with, X is acting as a positive and Y is acting as a negative. So A has to be with a negative, right? So A decides to get with Y. A and Y. And then X has to get with a negative. It's the only other free one. That's why you get XB. Okay, so it has to be positive, negative in chemistry. That's just how it rolls. All right, so let's look. I'll tell you about the solubility rules in a hot second. We will be doing everything ionically here. So in your heart, you know what to do. First cross charges. Okay, make sure because you will die in my heart if you don't first cross charges. Okay, so I'm gonna go over solubility rules in a hot second. Write down silver nitrate plus sodium chloride first.
Did you ever take your twins' test, like for chemistry tests?
We were in the same classes, except for one class.
Are you serious?
Yeah, every class.
We have 4 teachers.
Yeah.
You know how annoying that would be?
They just call it
But like, no, but not annoying like as you guys are annoying, but like, if you came up to the board and like, let's just say your sister's name was like Jane, you're like, yes, Jane,
I just heard people all the time. Yeah, it was annoying people talking about me.
like, you guys both start with J, that would be so much.
Is this Samantha?
Silver nitrate. You don't want it in the green line. Two most popular chemicals my mom can tell you. All right, Joe, help me out here, brother. Silver nitrate.
AG.
Oh, you were there talking like you knew with them.
No, I was asking questions.
Oh, okay.
You were trying to figure this out still. NO3.
Uh-huh.
2, 1.
Very good. Okay, so we're at number 1. So for number 1, 1 plus charge, nitrate, NO3, 1 minus, crisscross, nothing's there. Carrie, pick up from there, sodium chloride. Ethan, put your phone away.
There's sodium, of course, and then there's chlorine. Sodium has a positive charge,
So there's all 1 subscripts across the board here. Okay, so label underneath this right now. Silver plus nitrate, negative. Sodium plus chlorine, negative. This plus silver is going to get with who? The chlorine to make AgCl. Nice. And that's a 1 plus and a 1 minus. In the end, no subscripts. And this sodium plus is going to get with the nitrate to make sodium nitrate, NO3, just NaNO3. Okay. Is it balanced? Yay or nay?
Yes.
Yes, it is. Okay, done. I'm going to tell you about solubility in a second. Do lead to nitrate and cobalt to chlorate. Do those examples now. You guys are doing really well on time. Keep it up. You can see what facts in your pictures you go, so you want to. Austin, will you write those 2 examples? Write those down. The more you write it, the better you know it. No, always re-crisscross every time. Okay.
Because that's
Give me a thumbs up on the first one if you have it correct from the board. Sorry, I saw the heads looking down still. All right, so lead 2 nitrate, PbNO3, poo, crisscross that 2 over. Magnesium's got a 2, fluorine's got a 1, crisscross, MgF2. Where does this 2 come from? It's a lead. F is, so good question, sorry. F is diatomic when it's by itself. Like just F, not with PB. Where does that 2 come from?
Well, because of the lead.
Lead's crisscrossing its charge. And then where does this 2 come from?
The magnesium.
Magnesium's charge. You didn't just carry the 2 with it, right? I know it looks like it, but you didn't. You always re-crisscross charges. How many times did you re-crisscross charges here?
4.
4 times. 2 here and 2 here. So you crisscross charges quite a bit, yes.
So if it is like F2, you wouldn't carry that 2, you just drop the 2 that's in the reactants and then be crisscross to get it.
Yes, yes. Sometimes it does look as if you carry it around, but you don't. You actually re-crisscross every time. Okay. So yes, re-crisscross charges every single time you bring 2 new ions together. All right. Doing a third one, cobalt 2 Chlorate. So Rashida, tell me what this one is. Cobalt 2 chlorate.
CO and then parentheses ClO3
Okay.
plus Ca and then acetate and parentheses C2H3O2.
Okay, stop there for a second. Chris, pick up. I'm sorry. Can you? You can probably do it from here. I mean, even without having already doing it. CO is going to get with who?
Acetate.
C2H3O2. Beautiful, because the 2 from cobalt does crisscross down.
Plus Ca
Chlorate, calcium chlorate, to on the outside. All right, so all these 2's came from crisscrossing. So if they're all coming from crisscrossing, that means you always make sure that you are considering the charges every single time. Okay, so this one's already balanced as well. So in terms of the solubility rules, look on the back of your sheet where it says activity series. Right to the left-hand side, sometimes they're looking about left and right. You see where it says solubility rules? All right, so you get this. You just gotta know how to use it. So I have a version of, like, they come in many varieties. This one's kind of weird the way it's listed out, but the one I have on the board is a teeny bit different, so I'm going to just explain the basics to you from here, and then we'll work with this one. So the word soluble means what? You have to put some descriptors to it. Dissolve in, and so we're going to call that aqueous. So it means AQ, aqueous, okay? So if you dissolve in water, cool. You just write aqueous next to the compound, we're done. If you don't dissolve in water, we call you insoluble, so not soluble. So if you're not dissolving, what are you likely doing? You're still solid. There's a name for that. Precipitate. So either write downward facing arrow to say I'm a solid, I fall to the bottom of the container. Write PPT to say I'm a precipitate because I just don't dissolve very well in water. Or you can put solid to represent the same thing. Basically, all 3 of those mean the same thing. Okay, tomato, tomato. So what you're seeing here on these rules, and it's on yours as well, underneath the soluble category, what does it say? All what?
All nitrates.
Okay, so pause. All nitrates are soluble. Every single one of them are soluble every single time. So lead 2 nitrate, silver nitrate, potassium nitrate, blah, blah, blah nitrate, dinosaur nitrate, dog nitrate, whatever. Every single nitrate is soluble. What else? Kendall?
Acetate.
Acetates. Every single acetate is going to be soluble every single time. Jonathan, next. On here. So we said all the nitrates are soluble, all the acetates are soluble, and then what's next? Ammonium. And now I don't have NH4 up here, but anything with an NH4 plus charge will always be soluble. One more. Group 1A. Every single thing that's bonded to anything with group 1A will always be soluble. Then there's some exceptions. It says all the chlorate or chlorides, bromides, and iodides are soluble except for who?
Silver, lead, and mercury.
Look, silver, lead, and mercury. They're the heavy metals. They just generally don't dissolve very well when they're bonded to these compounds, but they're totally fine with nitrates and acetates and so forth. And then you have a couple of other exceptions as you go forward. All right, the insoluble categories. What's generally insoluble? What are some examples? All carbonates and phosphates, except for ammonium and alkali metals, right? Do you see that's because of our first rules up here? Yeah, Kenya?
So are we gonna, like, on the physics and the holy worksheets and stuff, are we gonna have this?
Mhm.
Or like, should we probably just done
You take a picture of it. That's fine. So, but we're going to use this right now to look at our 3 examples we just did, okay? So, utilizing this, if you can understand how to look at it and use your tool, you're good. If you don't know how to use your tool, it's just a piece of paper with words on it, right? So let's look at the ones we just did. And I want you guys to label either AQ, aqueous, or PPT for precipitate. Okay, silver nitrate. All nitrates are? Soluble. What are right here? Aqueous, AQ. Chlorides. Soluble. And guess what? Sodium, group 1 metal. Double whammy. Also soluble. AQ. Silver chloride. Don't guess. Use your tool. If you don't learn how to use your tool.
No exception.
So it is an exception. So it says chlorides are soluble except Silver. So what do I write? It's not soluble, so what do I write? PPT, solid, or downward facing arrow. Any of those work. All right. Nitrate. Soluble. AQ. Beautiful. Okay. How about, let's do this next one. Yeah. Oh, so the reason we're doing this is because if in a reaction you say, okay, watch this, liquid, added to liquid, and then it just looks like plain old liquid afterwards, is there any evidence of chemical change?
No.
Is there? No, so you probably assume a chemical reaction did not happen. But if you're like, liquid, added to liquid, oh my god, precipitate, evidence of chemical change. It actually basically tells you a reaction's happening. So while I'm on that topic, let me skip to, I'm going to go down to 3. All right, so I don't have chlorates on this example. This is like a small portion of the solubility rules. There's like hundreds of them, but we're going to go with this for now, okay? So chlorate, I will tell you all chlorates are also soluble. So what do you say about this one? AQ, yep, AQ, aqueous. How about acetate?
It's AQ.
AQ as well. All acetates are soluble according to your rules. Guess what? We have acetates and we have chlorates. So guys, what does this look like in a reaction? Imagine yourself.
All liquid.
Liquid. Added to liquid makes liquid and liquid. Did it happen? It's boring. Did it happen? No. This is called a big no reaction, guys. So after we go through the whole thing, if we find no precipitates, no gases, no fire and energy and bubbles and so forth, if we don't have any evidence of chemical changes, we write no reaction. And then sad face, because nobody likes no reaction. Yeah.
So if we do a lab, we're gonna have to like be able to name like all the different substances.
Name like this types of reaction that's occurring, and then
But like mix different things.
that's our lab tomorrow. It's called types of reaction lab. You're just figuring out what kind of types of reactions are happening. Okay. All right. So that's basically what you use the solubility rules for. All right. Let me give you a break because I have one more slide with combustion with some examples embedded with it. So get up and talk to somebody about what choice board project you're going to come to on Thursday.
I did most of mine and I'm doing names again. You figured out I'm like my scientist
We're taking a quick break. We're doing combustion.
But basically she figured it out, but then the other guy, like you're doing the same thing, you're like after you do your I'm so good.
I don't want to put like a Saturday.
What if I go like a doctor and I end up
All right, go back to your seats in 5, 4, 3, 2, 1. We'll talk, okay? Guys, last big slide of information. This goes on your combustion little flap. If you have questions about this, I'll do it at the end of class. This is all on my website from like a month and a half ago. So. So this is usually everybody's favorite one, because it's like combustion. What are some evidences of reaction?
Blowing up.
Gas evolution.
We're going to do combustion, which means react with oxygen. There's other side effects to that, yes. Out of fire and oh, I got you. I'm going to give you the safe examples first and do the non-safe ones tomorrow.
Oh, not safe.
Not as safe.
Oh, not as safe. Like, no.
I can't do anything not too safe with you because I like your eyebrows where they are.
But we can stand back. Like, you know, they have those like really long.
You can't outgrow that.
Actually, your facial hair teaches really well.
Decomposition and. So anyway, I love your fun facts for the day, but we did decomposition and then combustion on top of it. Okay. So if you guys were here Thursday, I did that the demonstration with the gummy bear.
Oh, yeah.
I was gonna say that was cool, but anyway, it made a decomposition reaction happen first. We decomposed the potassium chloride and made oxygen. Then I threw a stale gummy bear in there, which is glucose. A hydrocarbon, you say? Good example, guys. Okay, so the hydrocarbon reacted with oxygen, and then it basically did aerobic respiration, but outside of the body, because aerobic respiration happens in the mitochondria, makes ATP energy. Well, chemistry energy, a little bit more fiery and light-provoking than ATP energy. That's why we saw the light and flashes and fireworks happening in the fume hood, because it was making energy, but alongside of that was making carbon dioxide and water. And then it's just aerobic respiration, just without the 36 ATP. Yeah. Okay. So this one looks eerily similar to what other type? Yeah, it's basically just synthesis, but it's just specifically with oxygen. If you have a reactant, reacts with oxygen. If you have O2 as a reactant, we are going to call that combustion. Just for clarity's sake, we'll try to keep it calling it combustion. That's what these are. So if I do metal plus oxygen, it's just really synthesis, but we're going to call it combustion. And then this one's the more funky one. Who's heard of methane? Cow farts, right? Okay, ethane. Propane. Like propane tanks, like for a grill. What do you say? Yeah, it's for a grill. How about butane? Like a butane lighter? Yeah. It's didn't think of a big lighter. Like lighting a candle at home versus a match. Use a little thingy do, extendable lighter thingy do. Okay. So fancy names for fancy things. Okay, so that's what this combustion is really related to. It's what happens in your who's a driver? Who drives? Okay, loud and proud. Okay, so you burn octane in your gasoline tank. Octane is a form of a hydrocarbon. Okay, so let's look at the first example, and then I have a couple of examples. Oops, I gotta show you. I don't have a demonstration today. Okay, so this one and this one. Do those two first. If I just say aluminum combust, you're like, combust with what?
Oxygen.
Oxygen. Thank you. Write down those two reactants or reactants to your product. What did you say? Yeah. Well. Brandon, help me out here. Aluminum combust. Give me the two reactants. Al. Got you. So aluminum combust means reacts with oxygen. It's going to yield Brandon. Al2. Where does 2 come from, man? O3. Because what did you do? It's correct. You can't just Chris. You got to Chris and cross, right? You can't just Chris or just cross. You got to crisscross. So aluminum 3 plus charge, oxygen 2 minus charge, crisscross. So final answer. Oh no. So hold on. What are we doing now? It's not. Basically, we're breaking the law, right? We can't break the law. We have to balance this baby. I'm ready when you are.
Put it in front of the pot.
And in front of the what? Give me the name of it. Aluminum oxide, very good. And then
Two.
4 in front of aluminum, and then a 3 in front of oxygen. Okay. So,
Ours always so loud.
okay, so there's our aluminum oxide synthesis from a combustion of aluminum. Barium combust. Josh, start me off. I know I just got you started here. Go for it.
Ba. Plus two.
Plus
O2.
O2 yields.
Ba.
Why just BAO? Why are there no subscripts, man?
Because the charge is reduced.
Right, 2 from barium, 2 from oxygen, crisscross, reduce. And then balance.
So, 2 in front of barium on the reactor.
And
2 in front of barium oxide.
wonderful. You guys are speaking my language. This is nice. Finally we can communicate. Okay, let's do the last 2, which are the combustion of a hydrocarbon. So I'm going to scooch back and tell you what page this is in your book. 693. There was a section of, actually, somebody else may go back here, so I'm going to stay here for a moment. So there was a section of organic, nomenclature I did not teach you because you guys were already overwhelmed with polys. Well, those polys should be all up in your head now, memorize the things kind of with your charges and knowing when to crisscross. So, because I know that's where we should be, I'm still teaching like as if you were meeting my expectations. Okay, so in terms of meeting my expectations, you should have your stuff under your belt. Organic was something I didn't want to teach because you guys were overwhelmed, but I needed to give you a little bit of it because that's what combustion is kind of based off of. So let's just talk about the basics today, and then we'll add on a little bit more tomorrow. Hydrocarbons. Guess what 2 elements are involved? Hydrogen and carbon. But hydro and carbon actually doesn't go in that order, just like hydro or hydroxide doesn't. It goes C and then H. So methane is an example that you're already aware of. Write down these couple of examples with me, okay? So methane, ethane, propane. Chris, is that good? Is that what you needed? Okay. Methane, ethane, propane. Oops. Butane, not butane, okay? Butane. Pentane, hexane. I'll stop there. What do you see as a thread or as a common theme? Okay, so the prefixes change and then the anes stay. Okay, so methane, ethane, propane, butane, pentane, and hexane. These 2, you're like, I know what those are. Pent and hex, right? What do those mean? 5 and 6. So guess what all these mean? 1, 2, 3, 4, 5, 6, right? So write C. 1, 2, 3, 4, 5, 6. Okay. So the first name, so the prefix of this hydrocarbon, which we're calling blah 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 anes, those are all representing a number. So meth must mean 1, eth must mean 2, prop must mean 3, but 4, and then it's easy from there. Pent, and then hex, and then you can probably guess what the rest of them are. Heptane, octane, nonane, decane, and then dodecane. What's 11?
Dodecane.
Dodecane is 12.
Oh, you said dodecane, sorry.
No.
You said 10.
I know, I skipped to 12 because I don't know 11. Okay. All right, so anyway, 1 through 6. Decane? I don't know. All right, so back with me. C's all have the numbers that are designated. Now, the actual fact that these are all alkanes, they're just called alkanes because they're straight chain alkanes. They have a carbon attached to a carbon attached to a carbon. They all have a specific number of hydrogens. The way you get the hydrogens is you take 2n plus 2, where n is the number of carbons. 2n plus 2, where n is the number of carbons. So how many carbons are in in methane? 1, so 2 times 1, 2 plus 2, 4. CH4. Methane. Same story, 2n plus 2. Ethane gets a 2 for the carbons, so 2 times 2 plus 2. We're using this little green.
No, I just did my math.
Okay, we're on the same track now, okay? What's it for propane? C3H8. Butane. H10. And the list goes on, right? Okay, so the only thing is not everything ends in ane. We can have propene or propine. So I will elaborate on that more a little bit more tomorrow. Yeah.
Is that like the H and I, where you lose it?
It actually is different. It actually deals with bonding. So like propane looks like this. Draw your 3 C's together, 3 C's, right? How many bonds does every carbon have to get octet? It can't have 8 bonds. It has to have 4 bonds because each bond carries how many electrons? 2. So this carbon's already got 2. So it's going to get 4 more bonds. This is our hydrogens. This one's already bonded twice on either side, so it gets a top and bottom hydrogen. And then this one gets 3 more. Guess how many hydrogens are there? 8. Instead of taking our time to draw these every single time and then count the letters and put the symbols, we can just know how to do the nomenclature versus vice versa. Yeah.
So is the iron going to be another element?
No, let me give you one example because you guys are curious. So this is propane, right? Propene, ENE, which is different than propyne, YNE, takes one of these carbons, instead of saying, okay, you guys can singly bond together, we're going to make a double bond. So we'll take off 2 of these hydrogens and go, all right, guys, double bond. That way you still have 2, 4, 6, 8 octet, and that's called propene. And instead, if I wanted to go propyne, I just make a triple bond. And I take off 2 more hydrogens and say, okay, you guys are going to triple bond. That's what differs. Well, I'm going to be honest. It goes in order. Ane, A, right? Ene, E, Y, ein, last, single, double, triple. Anes, eins, enes. Okay? So I could have you determine probably the hydrogen count from my propene example. How many hydrogens were there? Oops. How many hydrogens are here? So that's C, I keep messing up, sorry. C3H what? C3H6. So if my rule of thumb for an ane was 2n plus 2, what's my rule of thumb over here for hydrogens?
2n.
Just 2n. So it's just 2 times 3. No pluses at the end. Okay? So that's our, so the enes example is 2n, period. No adding at the end. Ane to get to the number of hydrogens was 2n plus 2. Can you guess what ine's going to be? 2n minus 2. Because every single time you drop hydrogens, you're adding another bond, so it makes sense to lose a bond.
Thank you, judges, for participating in the JDF coin drive. In first place is Ms. Austin,
You can pack
second
up.
place is Mr. Curtis, and third place is Ms. Thoreau. Keep bringing in coins to win a Dunkin' Donuts breakfast.
So, because you guys worked fantastic today, pack up if you need to ask me some questions about the Concept 11's not due tomorrow. There's like I'd say you're probably 85% good to go. But keep progressing. That's why our double replacement
PS 11.
Yeah, I want No, you just gotta go.
You're not sure that you were voting second round, just
That's illegal. I got you.
It's on the back of something.
Yeah, it's in the back of your breathing.
No,
No?
got one. Stop.
How about that? I saw it.
Are the lecture examples on?
Not anymore, because we did a lot in class, and so I feel like you're okay. But these are the ones we were going to do more of. I didn't get to do all of them.
Okay.
Bye.
I have another. Yes, just